Most AI models can generate a web page. That is no longer impressive. The difficult part is making the page look like the product you asked for, fit the code base that already exists, survive different screen sizes, and improve when you say, "No, that is not what I meant." Kimi K3 is being marketed for exactly that problem. Moonshot says the model combines coding with native vision and can work with screenshots in the loop. It can generate a visual result, inspect what it produced, and modify the code based on what it sees. That sounds like a small feature. It actually changes the entire development loop. A text-only coding model works from an incomplete map. It can read the component tree, the CSS, the design tokens, and perhaps a written specification. But after the browser renders the page, the model may not see the real result. It does not automatically know that the card is too wide, the heading wraps badly, the empty state feels unfinished, or the mobile layout has collapsed. The code can be valid while the product is visibly wrong. A visual coding agent can close that gap. The loop should work like this. First, understand the target. That target might be a screenshot, a design file, an existing page, or a plain language description. The model needs to identify hierarchy before styling. What is primary? What is secondary? What action should attract attention? Which information must remain visible? And how the page should behave on smaller screens. Second, inspect the existing application. This step is more important than generation. The agent should find the current component library, spacing scale, typography rules, color variables, form patterns, routing conventions, state management, and tests. If the project already has a button, modal, and settings row component, creating 3 new versions is not creativity. It is technical debt. Third, make a narrow implementation. The model should change the fewest files required to produce the feature. It should preserve the architecture and use existing primitives. A visually impressive result is still a failure if it rewrites the application around itself. Fourth, render the page. Now vision becomes useful. The model can compare the actual browser output with the target and inspect details that source code alone does not reveal. Is the main action visually dominant? Do labels align? Does content overflow? Are loading, error, empty, and success states coherent? Does the mobile version remain usable? Fifth, correct one defect at a time. This is where visual agents often become dangerous. A model notices one spacing problem and rewrites the entire component. It fixes desktop and breaks mobile. It makes the screenshot more attractive while deleting accessibility behavior. A disciplined agent should identify the defect, locate the smallest responsible rule, modify that rule, render again, and verify that unrelated regions remain unchanged. That is visual debugging, not visual regeneration. Moonshot describes K3 as capable of true vision in the loop for front-end work, game development, 3-dimensional scenes, and computer-aided design. Its launch examples show the model iterating between code and live screenshots. But there is an important evidence boundary. Those are Moonshot's selected examples. They demonstrate what K3 can do under the company's setup. They do not prove that a random prompt will produce a production-quality interface. So the correct way to evaluate K3 for front-end development is not make a beautiful landing page. That prompt rewards visual novelty and hides engineering failure. Use an existing application. Give the model a target screenshot and 5 constraints. Use the existing design system. Do not add a styling library. Do not rewrite unrelated components. Support loading, error, and empty states. Pass the existing tests. Then score the result across 4 layers. Visual fidelity. Does it actually match the intended hierarchy, spacing, typography, and responsive behavior? Codebase fidelity. Did it reuse the project's patterns or create a parallel design system? Interaction fidelity. Do focus, validation, keyboard behavior, and state transitions still work? Correction quality. When shown a mismatch, did the model repair the responsible region or destabilize the whole page? That final layer may be the most important. The first generation tells you what the model can imagine. The correction round tells you whether you can collaborate with it. K3's 1 million token context could help here because the agent can potentially hold more of the repository, design documentation, and interaction history at once. Its long horizon training could help it continue through inspection, implementation, rendering, and repair. The same capabilities create risk. Moonshot warns that K3 can become excessively proactive when intent is ambiguous. In front-end work, that might mean redesigning navigation, renaming components, or introducing new patterns because the model believes they improve the product. The solution is not less capable AI. The solution is explicit authority. Tell the model which files it may change. Require a plan before editing. Require a screenshot after each meaningful visual change. Require tests. Require a final diff review. And block broad refactors unless a human approves them. So can Kimi K3 build better front ends? It has the right ingredients: coding, native vision, large context, tool use, and a render inspect correct loop. But the real advantage is not that it can generate more interface. The advantage appears only if it can see the current result, understand the mismatch, and change the exact piece responsible. A model that redraws everything after every complaint is not a designer. It is a slot machine. A useful visual agent preserves the product, repairs the defect, and proves the new state. That is the standard Kimi K3 has to meet.